In part 1 of this series, we explored how fossil fuels form deep underground and how engineers locate and extract oil, natural gas, and coal from the earth. But extraction is only the first step. Once fossil fuels reach the surface, they still need to be transported, processed, and converted into usable energy. This requires an enormous global network of infrastructure that moves fuel across continents and oceans every day. This network includes pipelines, tanker ships, refineries, storage facilities, and power plants. Together, these systems form the backbone of the global energy supply. Let's start with transportation. Oil and natural gas deposits are often located far from the places where fuel is actually used. Oil fields may be located in deserts, remote offshore locations, or sparsely populated regions. But the demand for energy is usually concentrated in cities and industrial centers. To bridge that gap, energy companies rely heavily on pipelines. Pipelines are one of the most efficient ways to transport large quantities of oil or gas over long distances. These pipelines can stretch for thousands of miles, crossing entire countries and even multiple continents. Inside the pipeline, pumps move crude oil through steel pipes buried underground. Pumping stations are placed along the pipeline at regular intervals to maintain pressure and keep the oil moving steadily. Natural gas pipelines work in a similar way, but instead of pumps, they use compressor stations. Because natural gas is less dense than liquids, compressors increase the pressure of the gas so it can travel efficiently through the pipeline network. Some of the world's largest pipeline systems span thousands of miles and connect multiple regions. These networks operate continuously, delivering energy supplies to refineries, storage terminals, and distribution systems. But pipelines can't transport fossil fuels everywhere. When oil needs to cross oceans or travel between continents, tanker ships become essential. Oil tankers are some of the largest ships ever built. The largest vessels, known as supertankers, can carry more than 2 million barrels of crude oil at once. These ships follow established shipping routes that connect major oil-producing regions with large energy-consuming countries. Natural gas transportation across oceans requires a different approach. Natural gas must be cooled to extremely low temperatures before it can be shipped efficiently. When cooled to around -162 degrees Celsius, natural gas becomes a liquid known as liquefied natural gas, or LNG. Liquefying natural gas reduces its volume dramatically, making it possible to transport large quantities in specialized LNG tankers. These tankers are equipped with insulated storage tanks that maintain the extremely cold temperatures needed to keep the gas in liquid form. Once LNG reaches its destination, it is transferred to facilities where it is warmed back into gas and fed into pipeline networks for distribution. But transporting crude oil is only part of the process. Crude oil cannot be used directly as fuel. It must first be refined. Oil refineries are complex industrial facilities designed to separate crude oil into different usable products. The refining process begins with distillation. Inside a refinery, crude oil is heated in large furnaces until it begins to vaporize. The vapor then enters tall distillation columns where different components separate based on their boiling points. Lighter products, such as gasoline and jet fuel, rise higher in the tower. Heavier products remain lower in the column. Through this process, refineries separate crude oil into many different materials. These include gasoline for cars, diesel fuel for trucks and heavy equipment, jet fuel for aircraft, heating oil for buildings, and petrochemical feedstocks used to manufacture plastics and chemicals. Refineries also produce materials used in asphalt, lubricants, and synthetic materials. In other words, crude oil is not just used for transportation fuels. It also serves as a raw material for a wide range of everyday products. Coal follows a somewhat different path. Instead of being refined into multiple products, coal is typically burned directly to generate electricity. Coal-fired power plants use large boilers to burn pulverized coal. The heat produced by combustion turns water into steam. That steam is used to spin large turbines connected to electrical generators. As the turbines spin, they produce electricity that flows into the power grid. Natural gas power plants operate in a similar way. In these plants, Natural gas is burned to produce high-temperature gases that spin turbines. These turbines drive generators that produce electricity for homes and businesses. Natural gas power plants are often more flexible than coal plants and can quickly increase or decrease electricity production depending on demand. Across the world, fossil fuel power plants still generate a large portion of global electricity. But the infrastructure supporting fossil fuels does not stop with extraction, transportation, and refining. Storage systems also play a critical role. Oil and gas are often stored in massive tanks or underground facilities before being distributed to customers. Some countries maintain strategic petroleum reserves, large stockpiles of oil stored underground to protect against supply disruptions. These reserves can help stabilize energy supplies during emergencies or sudden shortages. All of these systems, pipelines, tanker ships, refineries, storage facilities, and power plants, form an enormous global infrastructure network that keeps energy moving around the planet. Even as renewable energy technologies expand, fossil fuels remain deeply integrated into the global economy. Understanding how these systems work helps explain how modern societies power transportation, industry, and everyday life. From underground reservoirs to refineries and power plants, fossil fuels travel through an extensive chain of infrastructure before reaching the machines and technologies that use them. And like many of the systems explored on this channel, much of this infrastructure operates quietly in the background, out of sight, but essential to the functioning of the modern world. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.